In this video I show how to make simple stylized rain using Niagara. It is optimized for heavy rain usage. There are splash particles when the rain hits surfaces. Rain drips is covered too. The front of this bus stop has a row of drips. Here are some vehicles and a cannon with the rain drip applied around it. Splashes that hit non-grounded surfaces like the wall will not disappear immediately, so it looks like it drips off it. You can see the materials have all become shinier and reflective over time, which fakes water buildup. It gradually increases with the random's texture so it mimics puddles. I can turn the rain off and the shininess will slowly reduce until it is back to normal. The audio volume also adjusts based on the amount. The amount of rain can easily be changed along with other parameters, and here is a heavy rain variant. Here is the rain during day, although it looks a lot better at night or cloudy environments. I also show how to do GPU rain, which lets you add very heavy coverage. This example currently has a spawn count of 100,000, but it can go into millions. This does depend on your hardware. The only limitation is it does not have a feasible solution to do splashes without causing extreme lag, so it was omitted. It is included since you may want to cover very large areas such as an entire island with one particle. It is good for cutscenes too. Here is a cutscene example I did using the GPU rain. For close-ups, you can use the regular particle since it will have the splashes. Here is an example with different settings to make it look like blood rain. Here is an example of it in a cutscene. This uses the GPU rain since it is a long shot. Here is one final example. There are some disclaimers. First, the CPU variant, which is the main focus of the tutorial, needs to be optimized to be used and cannot cover large areas without affecting performance. As such, I show how to attach it to the player. This, however, is a single-player only solution. For multiplayer games, you will have to adapt it so it can be used without affecting performance but still seen by all players. Next, the system is more for a playable level rather than a cutscene. However, I have included a short segment covering GPU rain towards the end, which will let you cover large areas without affecting performance, so it is suitable for cutscenes, especially long shots. Finally, this is a more stylized rain setup. I left some suggestions at the end of the tutorial if you want a more realistic one. I will start a new third-person project for it, but you can make it in an existing project or any other template. Make sure starter content is enabled, however. I made it be night off camera. I used this tutorial I made, which is very quick and is also a free download, so you can just get it if you want to use the same one. I also added some models off camera to the scene. Most of them use a custom material setup, but these ones use Quixel. I did these off camera since it is just for testing and showcase purposes. For the rain splashes, they are detected by collision, so your meshes need accurate enough setups. For example, for this street lamp one, the default collision towards the top is not that accurate. I can use convex decomposition to break it up into smaller, more accurate chunks. Here is another lamp. This bus stop needs to be very accurate since it has an interior too and a curved top. So instead, I will set the collision complexity to use complex collision as simple. This makes it per poly collision, so is 100% accurate. It can however affect performance for higher poly models, but this one is not that much, so it is fine. You can alternatively make your own collision shapes externally, then use those, but for most, either the default, convex or complex collision should work. I will do the rest of them off camera. You can see the collision of all objects are accurate now, and I can walk into the bus stop too. Now make a new Niagara system. Choose the hanging particulates template. I will pause the timeline. First, I will make all the user parameters. Copy the ones I do, and you can add more later if you want for other controls. Also, I would recommend for now using the same default values, which again you can change later. This first one is the CPU rain, so I will keep rain amount relatively low. For spawn range, make sure the Z is a lot lower to something like 100. Wind min and max is basically the velocity. Now change emitter state to system. This ensures the particles can be killed after the lifetime runs out. For spawn rate, drag the rain amount parameter over it to set it. For lifetime in initialize particle, I will set it to a random float between 5 and 6. This kills the rain particles after this duration if it didn't collide with anything. In most cases it shouldn't be a problem since that particle will be long gone to the player view. The sprite size defaults here are suitable values I found, but you can change them if you want. It scales based on the multiplier parameter, so it is a lot easier to change them instead of having to change 2vector2ds for it. Use box/plane for the shape location, which determines the area the particles spawn in. Now add an add velocity module. Change it to random range vector and use the min and max parameters. You can delete these 4 modules since I won't use them. Add a collision module. Set the radius to something really small since it is for the individual raindrops. By default the trace channel here is world dynamic, so it will only collide with those objects. You can change them to a different one if you want. I will just change all my custom added models to block all dynamic. Now add a generate collision event module and change the delay to something like 0.5. Add kill particles module. Click the drop down and add the has collided condition so the particles are killed if they collide instead of waiting for the lifetime. Enable requires persistent ID as the collision events cannot be used otherwise. You can change the bounce to fixed if you want. In Sprite Renderer, change the alignment to velocity aligned so it faces the direction the rain is going in. Navigate to the default material and duplicate it. I will remove the sphere mask option since it isn't that good for rain. Change the material to the new one. Duplicate the emitter for the rain splash. Make the shown changes. I left the lifetime a bit longer so splashes from more vertical objects like walls will drip down instead of vanishing immediately. Adding the velocity in cone makes it spray up and around like you would expect in real life. Add a gravity force module so it will go downwards. For the source, select the rain emitter's collision event so it knows to spawn when the rain has collided. The spawn number is how many particles will spawn. It should be low. A value between 2 and 5 should be good. That is all for the rain particle. Now I will do the wetness system. I will get this muddy ground texture first for free from this website. You can use any. We only need the roughness texture, which should look like a puddle or water one. Import the texture. I will make mine brighter. Make a material parameter collection with a scalar parameter called rain mount. Make a material function called rain wetness and copy the shown code. This code darkens the material if wet and uses the lerp node to control the darkness intensity. For the diffuse, the top will be darkened by 40% while the rest is only 20%. This code is a slope mask, so it only applies to the top of the material. The as exterior parameter is used to determine if the material is positioned where it should be affected by rain and in turn should become wet. For example, interior objects like furniture in a house would have this disabled. Find the gold material from starter content and copy the macro code. This randomizes the puddle texture, even though tiling shouldn't be too recognizable anyway with the rain. The rain amount will be between 0 and 4. At a value of 2, the puddle effect will be at maximum intensity. At 4, the entire surface will be uniformly shiny. I will add it to this default material first. Open the master material and add the rain wetness function. Change the default value of rain amount to 4 just to test it. Set the material instances as exterior value to true now. It looks wet now. Adjust the brightness of your puddle texture as well after setting rain amount to 2 until you find a suitable one. Adjust the tiling values used until it looks right. I will add the rain wetness function to my other materials. I will do them off camera since it is just the same process. You can add it to your character too. Next I will get the sound. I got mine from Mixkit, which is free. I used light rain loop, but you can use any. Make an actor called rain volume. This is used to control the rain during runtime. Add the rain Niagara and audio. Then add a box. This is to visualize the spawn range. Copy the shown code in the construction script. This is so we can modify the user parameters on the blueprint. I will speed this part up as it is a bit self-explanatory. Make sure the parameter names are exactly how you added them in the Niagara. I made the actual color and opacity separate variables. I used 3 vector 2ds for each wind direction since it is more readable and easy to understand than single vector 3s for the min and max. Click the eye icon on all these variables so they can be changed in editor. Make sure to set the default color value to white with an opacity of 1. You can see the rain now. You can adjust the parameters easily. You may have noticed the rain takes a few seconds on begin play since the particle needs to start. You can leave it as is if that is okay, but if you want the game to start with the rain already there, you can override the warm-up settings. Values of 10 and 0.3 work well when the rain is not too high up. But you will need to adjust the tick count based on the Z position. For this night scene, an opacity of 1 is too strong, so I can reduce it easily here. I can invert the wind direction. The particles are killed on collision with the ground, so you don't see it below here. The splashes aren't working. I will reset the bounds back to dynamic. Fixed isn't really necessary here since the range will not be that high and will instead be attached to the player. Change this to spawned particles. I will also reduce the splash sizes. You can see the splashes working now. The rain does not go inside the bus stop as it also collides with it. If I want it to fall straight down, I can remove wind in X and Y. The splashes go through the bus stop. So copy the collision and kill particles module and paste it into the splash emitter. The rain interacts nicely with everything now. Also, I forgot to set the audio source to the rain sound, so make sure to do that. We can finally add it to the player. Open your character blueprint. Add the rain volume to it. Move it up. Open the rain volume. Copy the shown code in event graph. This ensures it doesn't rotate with the player, as we only need to update the location. This will change the global wetness amount every 0.01 seconds. The values used for this can all be changed. If the rain spawn count is below 100, it will decrease the wetness amount with a scaled value. Otherwise it increases with a value scaled between 100 and 10,000. Since the timer runs every 0.01 seconds, the amount to change should be lower to compensate for this. This makes the update smoother. This clears the timer if the wetness is at the min or max, since it doesn't need to run after that. This is used to smoothly change the rain amount. This sets the value to just above or below the threshold, so when it restarts, it won't automatically clear the timer. This timeline is for the audio, which takes a bit longer to start and end than the actual rain amount. In my character blueprint, we'll use the number keys to showcase the rain amount being changed in real time. You can use the functions however you want, such as in a proper weather system, or activate them differently. I will add a delay before the audio timeline. Here is how the final system looks in game. You can see the wetness gradually increasing with the puddles texture then uniform. Here is the rain in a day environment. I had to increase the opacity this time so it is more visible. You can use it however you want in any level, as it is customizable with all the parameters. I will now quickly show how to add rain drips, for example along the front of this bus stop, the points of this street lamp and the edge of this cannon. Add a new scalar parameter in the parameter collection called drip multiplier. This is so it adjusts based on the overall rain amount. Make a new Niagara parameter collection and choose the rain one. Duplicate the rain Niagara system and copy the shown changes. We are using plane instead of box this time since it is along surfaces or points. We replace velocity with gravity this time since even if we rotate the particle to match slanted angles, the rain should still drip downwards. Go to the rain volume construction script and add the shown code. Now you can add it to whatever object needs it. I added it to the bus stop and positioned it at the top front. Then I changed the spawn size to match. The old parameters are still there for some reason, but just ignore them. Here is how it looks. I will change the size so it is not as big. When I turn the rain off, the drips will slowly start to stop. We added the delay in the timeline so that it looks like the rain is coming to a stop and the remaining water will drip before stopping completely. I will add the rain drips to this lamppost blueprint. The spawn size should be a point, but I will make it 10 so it isn't a precise sharp point. Test the parameters until it looks nice. For the cannon I need it to be rotated at this angle. You can see when I rotate it, it spawns with the slant but it still drips downwards, which is why we added the gravity module. For this motorbike back mudguard, I want it to look like it slides off. Since we can't rotate it to follow the velocity, we can instead just add gravity in that direction as well. It doesn't arc that much, but since it is close to the ground anyway and the amount is very low, it doesn't really matter. I added the other rain drips off camera. Here is how they look. These statues have a single point of rain drips at the front. When I stop the rain, the drips also gradually stop, and also they have splashes too, which look nice. The final part of this video is optional and shows GPU rain. It is very quick to make. I removed the CPU rain from the character to show this. Duplicate the rain particle. Delete the splash emitter. There isn't really a performance effective way I could find to do splashes with GPU rain, so unfortunately is not included. If you know a way, please let me know in the comment section. Change the sim target to GPU computer sim, then make the bounce fixed, as the spawn range will be a lot higher for these. Delete the generate collision event module. I will disable the collision module. It actually does work if you use the GPU ray trace mode, but the splashes didn't look that natural with it. I will increase the rain amount to 100,000 and change the spawn range. Add it to the level. You can see even with 100,000 spawn count there is no lag. I can even change it to 500,000 and increase the spawn range, and there is no visible effect on performance. You can add the warm-up override to this too if you want it to start already spawned. You can make this into a separate volume blueprint actor like the CPU Rain 2, but I did it off camera since it is the exact same process. That is all for this video. If you enjoyed, like and subscribe for more content. You can download this project for free using the link in the description. Thanks for watching.